Well, it's pretty early on a Saturday morning and the birds are out, the clouds are out, and we're going to try to make a long distance HF communication. A bunch of you in previous radio content have asked in the comments how you talk hundreds of miles. Little handhelds go a few miles, fine, sure, it's dependent on a bunch of different factors, but what if you want to talk for hundreds of miles? Well, today we're going to try to make a contact 1,200 miles away in Arizona and talk to my friend Gaston of the Tech Prepper channel. We're trying to talk to him directly. This is part of his No Random Contacts program. Now, ham radio as a hobby, it's really fun to turn on the radio, see what's going on, and see who you can get a hold of. But in an emergency, you want to talk to a specific person and generally at a specific time. Now, right now, the conditions are not actually great. We're not sure if the band is completely opened up. There's a couple of big storm clouds in the way. And then over here, the position where we're transmitting from is going to have some electrical noise because of these high tension three-phase all these different factories on the industrial park here. That's going to be potentially an issue. But that's kind of the point of the exercise. In an emergency, the conditions are usually not in their favor. That's not just Murphy's Law. Usually the conditions are contributing to the emergency, and you may not have all the stuff that you need. This may not be possible to make the contact. Okay, we are 30 seconds into the video and we already have our first mistake. It is not 1,200 miles, it's more like 1,500 miles. We're gonna talk from Centerville, just outside of Nashville, to a remote location just outside of Phoenix, Arizona, and we've gotta go over all of these mountains here. It's gonna be a long shot with the amount of power that we have. So, we've got our antenna set up, and I've used this compass right here to figure out the 272 degrees. That's the heading that we need to get to our guy. And this is our comms plan. Specific times when we actually try to make contact on specific bands using specific modes. And then we've got contingency times. And our emergency communication is going to be the Garmin inReach satellite communication. To be perfectly honest, this is the only thing that I'm pretty 100% confident that it works. So we are all set with one minor issue. As I was using this radio previously this week, there's already been a snag. This radio inside of this man pack here is a Xiegu G90, which is a very cheap Chinese radio, 400 bucks, and its performance is actually fantastic, much better than it should be for the price. Now it's a digital radio inside, but there's no digital port coming out. So we're going from analog and CAT to digital using this handy little digi-rig thing here. But that connects through these ports on the side, and that is where we ran into the trouble. So this is a great example of why you should always be testing and using your gear pretty regularly, not just waiting for that emergency. I discovered this last night while I was trying to do some regular stuff, and it's a good thing that power was on, because I do have a USB powered soldering iron, so I could have done this with no electricity, except that the USB powered soldering iron doesn't work. So yeah, it's nice that we're doing this with power on. I'm gonna reassemble this thing and see if we fixed it. I will say that I kind of like this radio a little less now that I've had it open. Not necessarily just because it broke, but it's kind of a pain to put it back together. I can't help but think of better ways with less assembly that this product could have been made. And then there's the durability. These Armalock rails do a great job of protecting all the connectors on the back of the radio, all the controls on the front of the radio, but we have discovered the weakness here on the sides. First test is going to be power. Didn't catch on fire. Second test is going to be turning it on. It's alive! So that's all good signs. The final test is the most trickiest. We're going to plug directly into our repaired jack. Gently, gently. All right. Didn't fall off. So far, so good. turns out it didn't work. The radio works, the port works, the digi-rig works, everything is working fine, but it just won't talk to the computer, which is a shame because we have such a fantastic kit here. Gaston has put together a really awesome thing that I am disappointed that one part of it is a weak point. We have the little ToughPad computer with completely waterproof keyboard to do all of our digital modes. It is extremely cool. We have a good lithium iron phosphate battery. We have antennas, and then of course the radio itself, which I realize now is the weak link in the whole thing. The only part of the project that I actually supplied was this radio, and it worked really well up until the point that the one little data port stopped working. So the good news is we're not back to the drawing board. We have a whole bunch of working stuff, and it's even color coordinated too. So that is really nice. And all this stuff has been really well thought out, but we went just a little bit fragile on the radio. Again, this is my radio. I've had it for quite a while, and it's held up relatively well, and Gaston got it to work pretty well at his end, but something happened to it in between now and then, and it's still a great analog radio, and I do think that it's probably fixable, and I mean, it's definitely going to be easy to replace the front end since that is where the damage happened. So yeah, I do think that we'll get it working again, but we also are trying to, I think we're kind of pushing our luck with this radio here, because all of this stuff, the software that is on here, this very fancy computer setup, doing all of these things properly is not particularly cheap. And then trying to put the cheapest possible HF radio as part of that is a little bit like putting an O-light on your Daniel Defense rifle. Just, you know, you're gonna have the entire setup. It's gonna cost a lot. Don't let there be a particularly weak point. So this has been a very educational thing, but now I'm curious to see what it is that we're going to replace this G90 with. This is where our friend Jason comes in. So if this is not able to make analog communications and our digital capability is broken, we're a little bit in trouble. But fortunately, Jason has brought along some other stuff. This is a more powerful analog radio. And this is another digital radio option. So even if this isn't able to completely make the contact, we'll still be able to learn a lot of stuff. And we're going to tinker with and build a few tools to make our chance of success even just a little higher. Now, because this is not a real emergency, cell phone and internet are working fine. I could just put Gaston on speakerphone for the entire morning and we could just troubleshoot stuff that way. But this is a much more effective exercise if there is zero communication outside of HF radio and we stick to the plan. We'll learn a lot more this way. And if you want to know why HF signals go so much farther than regular VHF or UHF and why the antennas are so long, go check out our radio propagation video from a couple months ago. So Jason, tell me what it is that we're doing here. We've got our communication plan and we've got our 20-meter antenna. It's up and ready to go and pointed, and the meter says that it's operating pretty well. What you got?
So what I've done, we also have another antenna for the next portion of the comms plan where we're operating in the 18 megahertz frequency.
That's our contingency.
That's a contingency plan. What I've done though, that's an in-fed half-wave antenna. Mm-hmm. I'm kind of a more of a dipole guy when we're talking about these very directed contacts. Mm-hmm. So I put this together just as a backup plan. Had some extra wire with me and literally cobbled this thing together with a Leatherman in about 5 minutes or so. Yeah. We've still got to tune it, but as soon as we get it tuned up, that will give us nice. Another antenna.
Now this is an interesting point here because Gaston, the tech prepper himself, gave us a 17-meter antenna. And knowing him, I'm sure it's great. However, I've never used it. You haven't tested it.
I've never used it.
So this is one of those things where if you haven't tested your gear, but there's a thing that you know for sure works, sometimes the technically inferior option is the safest because you have the knowledge. So
yeah, Just more familiar with the dipole. I've never used that particular antenna that he sent you, and I just want a backup plan.
Yep. Yeah. No, this is. I think this is an important thing. There's a tendency for lots of people, probably people watching my channel, possibly people watching your channel, definitely me, to buy the good thing and stick it in the bag and know I have the good thing, so I'm going to be good. And I'm actually more familiar with a technically inferior option that I can make it run better than the thing that I've never tested and never tried.
Correct.
And never read about and never understood.
The best gear sitting in a bag does not do you a lot of good. You've got to get it out and play with it, practice with it, learn what it will do and what it won't do.
All right, so we're hearing some traffic on the frequency that we have chosen for our comms plan. This is part of the reason that we have multiple frequencies. Meanwhile, back in Arizona,
someone's on our frequency, which is just okay. Well, there's the Tennessee station.
Now, if this were an emergency, we would interrupt.
Yes.
But because this is a simulated emergency, they were here first, and there's a lot more of them, and they have more power.
Yes.
So this is why we have a contingency frequency, because in an emergency, well, and the other thing is, in a big emergency, everybody would be on the radio.
Right.
Right.
So having those established windows and established frequencies, we're going to listen to this frequency for 5 minutes or an hour, whatever your plan happens to be, and then we're going to shift to, a different frequency or a different band altogether to try, at a later point. Can be helpful, especially when the bands are congested like this.
Yeah.
All right, so we've only got about 20 seconds left in this window.
Yep.
The windows he's established are 5 minutes in length. So at 15:05 Zulu, which is basically in 10 seconds, we're going to roll up to the next indicated frequency on the list. Now, here's the next downside. We had a much quieter frequency at 14,330.
Yeah, it was.
So now you can hear all of this, which is something giving us interference on this particular frequency.
Yeah.
Just because we shifted a little bitty bit in the band may have made it impossible to actually hear Arizona.
Kilo 4, Foxtrot Mike Victor from Kilo Tango 7, Romeo Uniform November.
Do you think that is our electrical substation down the road, or?
Probably, possibly. It's kind of hard to say. But you don't know this when you're developing a comms plan, weeks or months in advance. Yeah. So, and it can change. This noise might not be here tomorrow if we came back at the same time.
Yeah.
Maybe it's a neighbor that's running a generator. Yeah. Or someone else that's just got a temporary solar panel set up to power their RV. That goes away. This noise may also go away.
If it is something permanent, this is another argument for getting out, running stations from your own area, so you get to know, like, that substation.
Yes.
You got to be this far away. The 3-phase inverters that CNP uses down here to run their giant Haas machines. It's a good thing it's Saturday, but I happen to know those makes the noise.
You've played this game before, huh?
We're pumping 80 watts, guys. Let's do 100. Kilo 4, Foxtrot Mike Victor from Kilo Tango 7, Romeo Uniform November. QSL?
So he calls us on the even minutes. We call him on the odd minutes. And it's his time to talk. Nothing. Kilo Tango 7, Romeo Uniform November. This is Kilo 4, Foxtrot Mike Victor. Come in. His call sign has a lot of syllables.
All right, so I'm guessing we're not going to make this window.
Yep.
Let's look at, okay, so our next one is going to be JS8 call at 14078.
Yep.
And that'll come up at 1515. So this is a longer window. He's given us 10 minutes inside of this window. So we'll wait till 315 Zulu, and then we'll just swap over from this radio, and we'll be using the 705 for that digital section.
This radio is what we're using for analog communications because of its greater power output, right?
Yes, and that is both a strength and a weakness. If we're running on battery, we're going to be eating up more battery because we're pulling more power from the battery. And when we're using digital, we don't really need that much power. So that's why I set up the 705 to do the digital side of it. It's only going to be putting out 10 watts. We do have the external battery hooked up to it, but that's really probably all we're going to need. You're going to need to do some calculations, so you know, all right, I'm only going to go out for 6 hours. I can get away with this size battery. But if I'm going to be going out for multiple days, I either have to put a solar panel in the mix to help recharge that, or I've got to carry a larger battery to get me by.
Yeah.
The other part of that equation, how much are you going to transmit?
Yes. I was going to ask about that because me personally, I generally don't like to talk. On a radio, I like to talk even less. I like to listen. So what's the power draw for this listening that we're doing right now?
This particular radio is around 600 milliamps power draw on receive. This one is half that. Even though it's got the nice large color screen, it's still half the draw to this radio.
So we can listen for days.
Yes, and one of the reasons I like this particular radio is because of its low draw while receiving.
Yeah. Now before we go into the digital part of the comms plan, let me explain why we're doing digital. Do you remember Morse code? Morse code is so much better at long distance, low power communication because it's a single clear tone that can be on a narrower piece of bandwidth, and it's easier to hear when it's on and off, as opposed to human voice that's often really hard to interpret. It needs more bandwidth and is just harder to hear through noise and other obstacles. And then digital modes are like that Morse code. They are specific tones, and they can be designed around cutting through interference and error correction and just communicating data faster than simple dashes and dots. And the one that we're going to be using is called JS8 call. It's based on the FT8 protocol, and it's incredibly good at exactly what we are trying to do. Very little power. It's going to go a long distance and be intelligible at long ranges, we hope. Another thing that I want to talk about is timing. For the analog voice parts of the comms plan, we have been broadcasting, no, that's wrong. We have been transmitting, and we have been listening on alternate minutes. So this is a great way to make sure that you are listening when the other person is talking and you are talking when the other person is listening, but it requires that you both have pretty accurate times to do that in, obviously. This is where GPS watches actually come in really handy. If you can get a GPS signal on your watch, you can have really good time signatures. The other thing you can do with your ham radio is you can tune into the Fort Collins radio stations that broadcast time on these frequencies over here. There's a bunch of different ways that you can get timing so that you're actually on the same plan as the other guys. Once you go to digital though, occasionally you need more accurate timing than just being more or less on the right minute. JS8 call requires that you be less than 2 seconds apart, I believe. Now the good news is that you can get that with a GPS watch. You can get that from the internet if the internet is working. You can get that from the Fort Collins radio stations if those are running. I think that's where the atomic clocks are. But the other thing that you can do with JS8 call is you can get it from other JS8 call guys. So we don't have to be on exact perfect time. I just have to be able to see JS8 call messages coming in and set my clock based on those, and then I can talk to those guys. The other thing that you could do is if you were trying to work around other JS8 call messages, you could be running at a different time signature that they are. Maybe squeeze some extra stuff in. So that is something that I want to tinker with and learn more about. But JS8 call is a fascinating piece of software, and Gaston has built his own software package called MCOM tools that you should look into, but I'm going to let him talk about that on his own channel. Now, using this Panasonic Toughbook and sweet metal keyboard here that Gaston has set up, we have our JS8 call set up. This is my call sign. This is where we control the radio. These are past messages that we have received, and this right here is where we type the messages that we want to send. The other thing that we have down here is the waterfall. If this were connected to our radio, we would see signals coming in across these bands, and we would be able to know when somebody is transmitting in a specific spot, and we would know not to transmit over top of them. So even if our time signatures were out of sync at the beginning, we would still have a visual representation of what is going on, and we could kind of figure some stuff out. So it is really robust for situations where there has been maybe less coordination than we have now. Okay, so we struck out on our first band because there were people talking over us. We struck out on our second band because there was RF interference. So we're switching to digital.
We're gonna alternate where I transmit on the even minutes and Isaac and or Jason will transmit on the odd ones.
Signal. So we're getting a message directed to me.
All right.
You can see this KT7 RUN, KM4 ACK, and then MSG. That means he's sending a message direct to us.
We can see it on the waterfall.
Correct.
A new message was received.
I do see some activity on the waterfall on 1500. This could be them, guys. Yep, we got KM4 ACK. Awesome.
He wants us to acknowledge. Send him.
We're looking at Alpha Alpha November, and we will,
Hear back a 7.
yes.
If it's him. So this is a very important part of emergency communications. We want to make sure this is actually our friend in Arizona, not a man in the middle. So these are the authentication tables that he made. Top grid first, side grid second, and there's multiple versions. So he asked for AAN, Alpha Alpha November. That is this grid, this column, that row. It is a 7. So really quick and easy way using very few characters to verify that the message is authentic and secure, although it's not secure now because you can see the one-time pad here on YouTube.
Wildfire evacuated. Running on batteries, self-support, 7 days.
All right. What?
So we'll just click OK here. My station is automatically acknowledging that we got a full copy on his message.
Nice. So one of the things that JSA call is great for, so obviously it is defeating some of the propagation and interference issues that we've run into. We're only just a little bit off from the voice channels where we were running into
Yes.
stuff. But what this would be great for is not so much back and forth communications, but updates where you and I go deal with an emergency thing, come back and see what messages, send updates, go continue to do our thing, come on back, check on those aircraft, come on back,
Right.
etc.
So we have bidirectional communication right now, fellas, and he basically put Roger, Roger, 17 meters at the top of the hour, question mark.
All right, so we have succeeded on the 20-meter band. Voice failed, secondary voice failed, primary data succeeded. So that is a win. We made contact, but we're gonna try again on our contingency with voice on a couple of different channels and then digital again using our Field Expedient 17-meter antenna. We'll see how it goes.
We'll try voice again first. So hopefully the nice thing about the 17-meter band is that it's a work band and not terribly crowded.
Yankee, Oscar, out here in the high desert.
Well, I got good news and bad news. That signal sounds great, but it is not the tech prepper in Arizona.
So, if you get a crystal that's lower in frequency, say you buy one that's on, 18 megacycles, won't bother rock at all. But hydrofluoric acid, by God, that'll have an impact on it.
Our channel is being used by some other ham radio guy. He's talking about something cool, but he's definitely talking about stuff on the whole band.
What's
All right, we're coming up on the time to switch to our next frequency. Second try at voice on 17 meters. And once again, our second channel has some interference on it.
a little bit more noise than where we just were?
This is RF interference or electrical noise, not people talking. It's going to be hard to hear through that. Kilo Tango 7, Romeo Uniform November. This is Kilo 4, Foxtrot Mike Victor.
And then what's our time to roll to digital?
We will roll to digital in 3 minutes.
Okay.
Voice appears to be a bust today, even at 100 watts. All right, we're gonna switch from our analog radio to our digital. As simple as swapping the antenna.
If there's a signal there, I am not seeing it.
Okay. Just noise.
Yeah, I'm seeing this noise over here, but I'm not seeing anything in the middle.
Okay, so it is no longer early in the morning, and this is not the most grueling test environment since we're literally right in front of the shop, but here is the final score. We essentially had 4 different ways of communicating across 2 different bands, and our success rate is 1 out of 4, which in one sense is a fail, but overall it is a success because the goal was to make contact. We managed to do that. And there is actually a emergency communication method, the Garmin InReach, that also worked perfectly. I was able to send a message to Gaston, he was able to send a message back, and it went all the way up through space with, I think, less time than it took to transmit over JS8 call. So infrastructure is cool when it's there. This is cool when it's not there. So now we're gonna start to pack up this stuff. Another experimental training day over, and we're gonna have some thoughts about how we do this next time. Minor tweaks, minor changes, but all in all, a tremendous day. So all in all, it was a success, but more important, it was a great learning experience. It felt like we overcame a few obstacles, but there were a lot of obstacles we didn't overcome, and those are great learning opportunities. Kind of like your first competition where you are actually shooting against other competitors and on the clock for the first time. You will learn things that you didn't know that you were actually going to learn. And you will change your opinion of some of your gear in that circumstance. And I've kind of changed my opinion of this radio a little bit based on that digital port. Now on the plus side, this is a great radio. It performs incredibly well. It gives you great bang for your buck. It has fantastic features like an automatic tuner, so you can use just random pieces of wire for antennas, barbed wire fences, and all kinds of just pieces of metal lying around. It's very, very cool, but it has a specific set of weak points. And the annoying thing is this is a great budget radio, but for $2 they could have fixed some of the weak points. So I'm not as interested in using this radio for anything other than just sort of local analog HF at 20 watts. I'm probably going to put this in a car and do some NVIS experiments with it. But I am far more interested in doing the digital communication methods. I want to spend a lot more time in JS8 call figuring that out. And until we fix this datacom port right here, this isn't gonna actually be any good for that. I actually want something smaller and more lightweight. I'm very intrigued by the radio that Jason had, but you know, I could buy 3 or 4 of these for the cost of that radio. So the cost is kind of a thing. And that's where we run into a bit of an issue. I would love to see radio manufacturers lean into kind of a new breed of ham radio guys who are more like Gaston, guys who are more like me, guys who are a little bit different than the ones that we heard on the radio. People who are less interested in tinkering and experimenting with a whole bunch of different random bits and pieces, and people who want kind of HF radio appliances that work like tools. And the G90 is actually a perfect example of that kind of older ham mentality, because this is a digital radio. It is probably running Linux under the hood. It is an SDR. There is very little analog inside of this thing, and yet there is no USB port. There's no way for me to talk to the computer that is this radio except through this analog headphone jack that is just barely held on. That demonstrates that this radio, despite being a very advanced modern digital computer, the manufacturer still thinks that we want to talk to it using a whole bunch of different little adapters, old school ham style. But I would prefer that there be options out there for people that just want to use this device as a tool. The other thing that I want to do is I would love to get a JS8 call app for Android, because you could build a very small and simple HF kit. There are small HF radio transceivers that come in kits, and they fit in Altoid tins. They're just extremely minimalistic, and you can run those off of, you know, your USB powered batteries, and then you can connect stuff up with short cables. And obviously there are still some physical limitations to HF. You need very long antennas, but those wrap up in a really small space as well. So you could build an extremely capable long-range HF rig using really lightweight pocketable parts that would give you a huge amount of distance with not very much power. That's something that is really fascinating to me. It's kind of like the old days of the Altoid QRP radios, where people would try to run on just a tiny amount of wattage. They'd give themselves really significant weight restrictions to try to operate inside and then make super long contacts with. Very fascinating. Actually, that reminds me of World War II spies that used to have HF radio, or back then they called it shortwave, radio equipment. They would sneak behind enemy lines. They would string up wire antennas in places where they wouldn't be noticed, and then they'd send as fast as possible short, abbreviated military information back to the front. Then they'd pull down the radio stuff and disappear with it as quickly as possible. This is more like this kind of stuff that they wanted to carry around back then to communicate vital information with some other constraints that they were working inside. So I would like you to follow the Tech Prepper on YouTube. Not only is he doing the actual work on a regular basis of building and experimenting with stuff, he's also building out that software. He's building out that software around radios that are off the shelf, but also is working on firmware inside of other radios. So he is a fantastic resource. And then also Jason. We couldn't have made this video. We couldn't have made Contact. We couldn't have made any of this work without Jason, so follow his channel as well. Link to those. And yeah, let us know in the comments what stuff you would like to try to do with this radio stuff. There's always handheld radios and talking to people that are very nearby. But as soon as you want to go hundreds of miles or thousands of miles, you are entering an entirely new universe of stuff and an entirely new world of RF propagation that needs to be figured out. So it's very interesting stuff, but it has tremendous, tremendous opportunities. So this mast made right here in Tennessee is fantastic. It just friction locks. It is made of fiberglass and super lightweight, goes 30 plus feet in the air, I believe. Yeah, I'm getting one. That's a good takeaway. So this field expedient 17 millimeter antenna. Now on the one hand, we failed to make contact on 17 meters with Gaston, but the antenna did not fail. We could hear an awful lot of traffic on 17 meters, so the antenna was a success. These field expedient Kydex tent pegs are super handy. Flat, fit in the bag, weigh nothing, work pretty well in normal soil. So that worked well.